Okay, guys, here's how we are going to be doing this today. I bring up this worksheet, okay, and I am going to answer these questions as we go through them, and you're going to write down the answers, okay? Now, you're going to have some free thought on some of these, so if you need to pause so you have some time to write, go right ahead, okay? So bring up this worksheet, and you can write on your own separate sheet of paper, okay? And we're going to answer these questions. So we're starting chapter 7, and it's about oscillating objects or harmonic motion. Okay, so first thing we're going to talk about is a pendulum. Okay, so what is a pendulum? So that's the first question here. So let's answer that question. What is a pendulum? So to answer that question, as you can see, I have a pot hanging from, oh, it's hard to point on this. Okay, from the ceiling here, from a string. Okay, so that's a pendulum. A pendulum is any mass hanging from a string. It could be hanging from like a rod or something too. So we have a pendulum. We have a mass hanging from a string. Okay, and then the next question. Okay, so that's the answer to the first question. Now the next question is, what is a period and what are its units? Okay, we're not talking about a period at the end of a sentence. Don't write that. Okay, do put a period at the end of the sentence. But a period for a harmonic motion is the time it takes to complete one oscillation. Okay, so one cycle. So here, I'm going to do a period right here. Now, if I had a clock or something, I would time it for you. Okay, so here's a period. Right there, that's one period. Okay, the time it takes to go forward and backwards. Okay, so what are the units? Well, it's time, it's seconds. Okay, so let's just show a period one more time. There we go, that's one period. Okay, time it takes to complete one cycle. Okay, the next question is what is frequency and what are its units? Okay, so frequency is how many cycles it completes in 1 second. Okay, so it's like if you're timing out 1 second, you would count how many times it goes backwards and forwards. Okay, and in this case, it might not even complete one full cycle in 1 second, so it might be a decimal, like 0.5 or something. And here, let's do those real quick so you can get a better idea. So I'm going to bring up a stop watch on my phone here, and we'll time it, okay? And so first we'll start with a period, okay? So we'll time a period so you get the idea of that. Okay, so I'm going to start this right when I let go and stop it when I catch it, okay? So 1, 2, 3. Okay. So what I have here is it took 2 seconds, 2.04 seconds to complete one cycle. So my period here is 2.04 seconds. Okay? Now, if I was asked what is the frequency, well, to find the frequency, it would be how many cycles it completes in 1 second. Well, in this case, it completed in 1 second. Watch, here's what I'll do. I'll reset this, and I'm going to time out 1 second and see how much it completes, okay? So I'll just 1, 2, 3, go. Okay, so there, I got 1 second. It completed about half of an oscillation. So the frequency on it is 0.5 because it went through half of one oscillation in the time. And the units for frequency are hertz, Hz, okay? And we'll talk more about those on the next lesson, okay? Frequency is a little more difficult to understand than period, but that's not a problem. We're not going to focus on that real strong on this lesson right now, okay? So you got the idea of a period and frequency right now. Period is the time it takes to complete one cycle. Its units would be seconds. Frequency is the amount of cycles it completes in 1 second, okay? And its units are hertz, Hz, okay? I know, it's a lot. Okay, so now let's look at what's next here. It says create a pendulum with any length string. The longer you make it, the more accurate, and find the period of your pendulum and record it. Okay, we just did that. I made a pendulum of any length string, and I recorded how much time it took, and it was 2.04 seconds. So write that down. That's going to be your answer for number 4. Okay, the next one. Do you believe changing the weight at the end of the pendulum will change the period? And why? Okay, so I need you to pause the video and answer if you think if I put a larger object on here, something with more mass, will it change how much time it takes to complete one cycle? Okay, so you can pause it, you can answer that question. Okay, now here's what we're going to do. I want you, it says change the mass at the end of the pendulum and find out if your educated guess was correct. Okay, so what I'm going to do is I've set up some pendulums outside and I put different masses on them. And let's see if it changes it, okay? So let's go outside of Casa de Campbell. I hope it's not harder to see in the sunlight and everything. Haven't really tested this out too much. Okay, here we go. Here are these posts I've put together. And you can see here, I have a mass hanging on the end of it, okay? And I have a wrench, yeah? Okay, so here's one period. If I let go of it, that was one period, right? Okay, well, on this other post behind it, which I don't think you can see as well, I've put another wrench, but a much smaller one, yeah? So this one has much more mass than this one. So, but I've made them the same length string. So the question is, do you think that the mass will change how it cycle, how much time it takes, right? So what I'm going to do is I'm going to let go of both of these, and basically I'm going to let go of them at the same place, and you're going to tell me which one do you think is going to reach back to its original position first, yeah? Do you think the heavier one will complete one cycle faster, or the lighter one will complete one cycle faster? Okay, so get your guesses. Here we go. 1, 2, 3. Yeah, they were about the same. And watch, I can let them go for a little longer so you can get a better idea here. See? So the mass at the end of the string does not change how much time it takes to complete one cycle. So I could hang an elephant from the end of the string, and it'll be the same amount of time to complete a cycle as if I was hanging from the end of the string. Okay? So mass does not matter on pendulums. Okay, so let's look at the next question. Okay, the next question is, okay, change the mass at the end of the pendulum. Okay, do you believe changing the height at which you let go of the string of the pendulum will change the period? Okay, so what I'll do is with these two pendulums behind me, I'll release them from different heights, and we'll see which one completes the cycle first. Okay, so get your guesses ready. So I'll release the bigger one from a higher height, the smaller one from a smaller height, and we'll see which ones get back to their original positions first. So take your guesses, which one will do so. Do you think the one dropped from a higher height will reach back to its original position faster because it gains more speed maybe? Or do you think the one dropped from a lower height will get back to its original position quicker because maybe it has less distance to travel? Okay, so let's see here. Okay, 1, 2, 3. Now I'll let it run through a couple cycles. It looks like they took about the same amount of time. So it doesn't matter with the amount of height that you let it go at. It still completes the cycle in the exact same amount of time. Yeah? So if we were to time it, like on the other pendulum I made, it took 2 seconds, right? So let's say it's 2 seconds here. It would take 2 seconds to do this, and it would take 2 seconds to do this, and it would take 2 seconds to do this, 2 seconds to do this. The period will always be the same no matter where you let go of it, no matter what the height is. It's crazy. They used to make grandfather clocks out of these pendulums because they were great ways to track time, because it doesn't matter how much energy is lost, it will always take the same amount of time to complete one cycle. Okay, so now let's look at the next question here. Let go of the pendulum at a small height and a large height and test your results. Okay, so that's just what we did right now, yeah? And what were your results? Well, we found out that the pendulum released from the highest height and the lowest height, it didn't matter. They would still complete one cycle or a period in the same amount of time. Okay, do you believe changing the length of the string will change the period? Okay, so what we need to do is change the length of the string. Make one of these guys shorter than the other, and see if it takes more time to complete a cycle in that with that given. So what I will do is I will jump up there and I will change the height of the smaller one. Okay, so now I got a pendulum that's shorter and a pendulum that's longer. Okay, so I've changed the length, as you can see here. Okay, so now which one do you think will complete a cycle faster? Do you think the longer one will complete a cycle faster, or the shorter one? Okay, or do you think it's going to take the same amount of time, just like the other ones did, right? Okay, so I'm going to let go, and you can see if your guess was correct. Okay, here we go. 1, 2, 3. As you can see, the shorter one completes the cycle faster, right? Let's look at it again. Yeah? So the shorter one completes a cycle faster. So the length of the string does matter. The shorter string will take less time to do a cycle than the longer string. Okay? So length of the string does matter. Okay, so let's look at the next question here. We're getting near the end. Change the length of the string and tell me what you find out. So we changed the length of the string. We found out that the shorter string will finish a cycle or go through a period faster than the longer string. Okay, so what factors affect a pendulum? Okay, well, we figured out that out of all the things we tested, the only thing that changed how much time it takes to complete a cycle is the length of the string. That was the only thing we found out. There is one more thing, but I can't change it here to show you because we're on Earth. And the other thing that will change how much time it takes to complete a cycle is gravity. And since gravity is relatively the same everywhere where we are, I can't change that value to show you. So the two factors that affect the period of a pendulum is length of the string and gravity. Okay? And the last question is, what is the formula from the formula chart for the period of a pendulum? Okay, now I'm going to go grab my piece of paper and I'm going to write it out for you, and you just need to write down the formula, and we will be using this formula in future lessons. Okay, so I think I got one right in here. Yeah. Okay, so let me make this big again, and here's the formula that we're going to be using for the period of a pendulum from here on out. Okay, and we'll write down what all the letters stand for. Okay, it's big T. The T stands for time or period. Okay, so this is period, and we measure it in seconds. Okay, so there you go. That's period is equal to 2 pi square root of L over G. Okay, now remember I said there are only two things that change the period. There are only two things. It's so hard to point on this thing. Okay, there are only two things. 2 pi is a constant. Okay, so the two things that change it, we said, was the length of the string, L. Okay, so length of the string, and we measure that in meters. Okay, so I'll put it in parentheses. We measure that in, so length of the string, and we measure that in meters. Okay, and then G stands for gravity. So G is going to be gravity, and as long as we're on Earth, that gravity is going to be 9.8, okay? And that is in meters per second squared, because remember, gravity is an acceleration, okay? So there's our formula. Write it down, and write what all the units are and everything. I'm trying to make it sit in the center. Okay, and there's your formula, and now you're done with the worksheet, okay? And you can start the next one already if you'd like. I hope you learned something. I hope it blew your mind because pendulums are crazy. And I hope coronavirus isn't driving you crazy. I'll talk to you in a bit.